So hi guys, mayong adlaw. Welcome to NatzMath TV. So for today's video, I will be presenting to you about division of rational algebraic expression. This is the continuation of the lesson in my previous video about multiplication of rational algebraic expression. So we will start this lesson after this intro. So division of rational algebraic expression. So how do we divide a rational algebraic expression? So when we divide a rational algebraic expression, there is only one thing that we need to remember. We just simply get the reciprocal of the divisor and proceed to the rule on multiplication. So division of rational algebraic expression is just similar to multiplication of rational algebraic expression, only that we get the reciprocal of the divisor before we proceed to the rule on multiplication. So without further ado, we proceed directly to our examples. So let us try example number 1. Example number 1, we are given this rational algebraic expression x over 4 divided by x squared over 9. So we have here two fractions. This is our first fraction, x over 4, and this is our second fraction, x squared over 8. So which of these two fractions is our divisor? So in division of fractions, the second fraction is what we call the divisor. The first fraction is what we call the dividend. So therefore, we need to get the reciprocal of this fraction. So when we say reciprocal, it is just the reverse of the fraction. So if we have here x squared over 8, so the reverse of that fraction is 8 over x squared. So this becomes, we just simply copy our first fraction, which is the dividend, so that is x over 4. Then we get the reciprocal of this fraction, that becomes 8 over x squared. So the reverse of the given fraction. Denominator becomes the numerator and the numerator becomes the denominator. Now as you have observed, since we already got the reciprocal of the divisor, so we now proceed to the rule on multiplication. So as you have observed here, this is now multiplication instead of division because we have already the reciprocal of our divisor. So next step, we will proceed to the rule on multiplication. Of course, we factor out each numerator and denominator. So we start with the first fraction, x over 4. So the numerator here is x, and since x is already not factorable, so therefore that shall remain as x. Now let us proceed to the denominator. So we have here 4. 4, we can factor out 4 2 times 2. So since we have the 8 here, so we can just leave 4 as is here. So we can have 4. Again, we can factor out 4 2 times 2. But since we have the 8 here, and we can factor out 8 as 4 times 2. And we can also factor out 8 2 times 2 times 2. But the purpose here is to cancel out common factor. That's why we do not factor out the 4 here, and we factor out 8 as 4 times 2, since we can have 4 and 4 here. Or we can have 2 times 2 times 2, and here we have 2 times 2. So let us proceed to the denominator. So we have here x squared. We can factor out x squared as x times x. Then afterwards, we can now cancel out common factors in the numerator and denominator. So first common factor, we have x and x. And the second common factor is, of course, we have 4 and 4. So the remaining factor in the numerator is 2. And the remaining factor in the denominator is x. So therefore, what remains is 2 over x. So our final answer is 2 over x. Now let's proceed to our second example. Example number 2. We are given this rational algebraic expression. We have 3x squared over 10y divided by 12xy over 5y squared. Again, this is our second fraction, so this is our divisor. So we copy the first fraction, that is 3x squared over 10y. Then we get the reciprocal of this fraction, so we now have 5y squared over 12xy. Then after getting the reciprocal of the divisor, we proceed to the rule on multiplication instead of division. Then afterwards, of course, we have to factor out each numerator and denominator. So for the first numerator, we have 3x squared. We can factor this out by using prime factorization. So we can factor this out by having 3 times x, since 3 is not factorable since this is a prime number. So 3 times x will give us 3x squared. Now for the denominator, we have here 10y. So we can factor out 10 by factoring 5 times 2 times y. 5 times 2 is 10 times y is 10y. Then for the second fraction, so we have here 5y squared. We factor out 5y squared, we can have 5 times y times y. And for the 12, we can have 3 times 2, which is 6, and 6 times 2 is 12, then times x times y. So these are what we call prime factorization. Then afterwards, we evaluate the numerator and denominator. We try to check if there are common factors. So we cancel out the first common factor. So we have here 3 in the numerator and 3 in the denominator. So we cancel this out. Another is we have 5 in the numerator and 5 in the denominator. So we cancel this out. So another common factor is x and x. So we cancel out x. Then we have y and y. Then another y and y here. So what remains in the numerator is only the x, this one here. And for the denominator, we have 2, 2, and 2. So the remaining factor in the numerator is x, and we multiply the denominator 2 times 2 times 2, that is 8. So our final answer is x over 8. Next example. Example number 3. We are given this rational algebraic expression. We have x minus y over 5x divided by x squared minus y squared over 10y squared. So again, we get the reciprocal of this fraction. This is our divisor. We copy the first fraction, x minus y over 5x. Then we have 10y squared over x squared minus y squared, the reciprocal of this fraction. Then after getting the reciprocal, we proceed to the rule on multiplication instead of division. Then afterwards, we factor out each numerator and denominator. So we have here the first numerator, x minus y. So since x minus y is not factorable, so we just simply copy x minus y. For the denominator, we have 5x, we can have 5 times x. Then for the next numerator, we have 10y squared. So we can factor out 10y squared. We have 5 times 2, which is 10, then times y, that is equal to 10y squared. Then for the denominator, x squared y squared, since this is sum and difference of squares, so we can factor this out by having x minus y times x plus y. So these are now the factors. We now start canceling common factors in the numerator and denominator. So first common factor, we have x minus y and x minus y. Another common factor, we have 5 and 5. So we have no more common factors in the numerator and denominator. So what remains in the numerator is 2 times y, which is equal to 2y squared. Then we have x times the binomial x plus y, so that's why we have x times x plus y. So this is now our final answer. Next example, example number 4. We are given b minus 2 over a squared plus a divided by b squared minus 4 over a plus 1. Okay, the same process. We get the reciprocal of this fraction. We copy the first fraction. So we copy b minus 2 over a squared plus a. Then the reciprocal of this fraction is a plus 1 over b squared minus 4. Then proceed to multiplication. Then afterwards, we factor out b minus 2 is not factorable, so copy b minus 2. But for the denominator, a squared plus a, we have the common factor here, which is a. So we factor out the a, so what remains shall be a plus 1. So common factor is a. If we want to check if this is correct, so we just simply multiply, distribute the a to the terms inside the parentheses. So we have a times a squared, and a times 1 is a. Then, for the next fraction, we have a plus 1. So, a plus 1 is not factorable, so we have a plus 1. Then, b squared minus 4. Again, this is sum difference of squares, so we can factor this out. We have b minus 2 times b plus 2. We cancel out common factors. So, we have the first common factor, b minus 2, and the second common factor, a plus 1. Now, as you have observed in the numerator, we have cancelled all the common factors, so what remains here is 1. Then, the denominator, we have a and the b plus 2, so we have a times b plus 2. So, our final answer is 1 over a times b plus 2. Now, let us proceed to our last example, example number 5. We are given this rational algebraic expression, 5 over 2n divided by 10m minus 5n over 3n. So, we get the reciprocal of this divisor. So, we copy the first fraction, 5 over 2n, then the reciprocal, we have 3n over 10m minus 5n. Then factor out. Since 5 is not factorable, so we copy 5. We factor out 2n, so that is 2 times n. The same also with 3n, that is 3 times n. Now for the denominator, 10m minus 5n. So our common factor here between this first term and second term is of course 5. So we factor out the 5. So what remains for 10m shall be 2m. And what remains for 5n shall be n. Because when we multiply 5 times 2m, that is 10m. And 5 times n is 5n. Then afterwards, we cancel out common factor. First common factor, we have 5 and 5. Another is n. So what remains in the numerator is of course 3. And the denominator is 2 times 2m minus n. So this is now our final answer. Okay, that's it. I hope you have learned something from this video. Please do not forget to subscribe, like, and share to your friends, especially those who are grade 9 students. So for now, thank you and God bless.